So this video is basically on collecting biotic data in our transects. So you're going to have a belt transect or a line transect or grids in a transect, and you're going to be collecting data. And this video is about collecting data on the living things in those transects. So essentially, when you go into those transects, you need to make sure you don't miss any living organisms. So when you look at an ecosystem, there are many different types of living organisms that are there. You just need to make sure you don't miss them. The very first one you're going to want to go and count is the plants. They're nice, they're easy, they don't tend to move, and unless they're something like grass that's really thoroughly thick, they're actually not that hard to count. So you're going to be counting your plants first thing, and when you go out there with pieces of paper to write down some of your information on, one of the first things I'll do is split it up into trees, shrubs, ferns and climbers. It's a pretty easy way to break it down a little bit to make sure that you've got everything that's in your quadrat there. So that's one of the first things that you're going to be learning how to count in your squares. But there's also other types of little plants that we often tend to miss if we don't look for them. Any presences of lichens and mosses, especially on trees or on logs and stuff. Fungi, any of the debris or fallen down trees and stuff that are in your quadrats, you may not be able to count it all, but you can certainly identify its presence there, take a photo, and we can try and estimate how much of that fungi is actually present. Animals are one of the other ones that we tend to not count when we're on biology camps unless we're asked to, because they tend to move around and they're pretty hard to catch. So once you've done a preliminary plant analysis of your quadrat, then I'll get you to pull out your magnifying glasses and stuff and look for evidence of animals. It doesn't have to be actual animals. Evidence of animals is still valid data. So scat is one of the main identifiers for a lot of animals. If you find any leftover remnants of poo, that's one of the ways we identify who's been there when we weren't there. Kangaroos on our school oval and that leave scat around all the time. But also getting in there and looking for evidence for a lot of the vertebrates and invertebrates that are living there, or any birds that are in the area. They're one of the things that you need to take notice of. And just note down, even if you can't count them, that there is evidence of their presence in your quadrat. Last but not least, we don't do this in most of the school biology, but evidence of microbial species is incredibly important these days. Any scientist will actually do a detailed investigation into the microbes in an area. The microbes in the air, the microbes in the water, and the microbes that are in the soil, because that actually is a very distinctive and definitive way to tell how healthy an ecosystem is. Heck, they can test the microbes in you to actually determine not just how healthy you are, but it will also give a pretty good estimate of how long you will live, depending on the microbes that are surviving in your stomach. So microbial species, we won't be doing it now, but in future that's going to be a very major part of any ecosystem investigation. Last but not least is canopy cover. That's pretty much looking at all of the different plant species and how they block out the sunlight from the ground. And we usually do that by analysing the amount of sunlight that's coming through. There's different methods that you can do it with tech to try and estimate canopy cover. Myself, I'm actually starting to simply turn my phone around, put it onto selfie mode, stick the phone in the middle of the quadrat and press photo. And it comes out with a pretty good photograph that actually shows you, and you can use to calculate canopy cover without your head getting in the way or without having to try and look at shadows on the ground. That'll be demonstrated to you by your teacher when we're doing our actual surveys. Now, analysing that data, what the heck do we do with it? Well, you're going to be first of all doing stuff on abundance. Abundance basically means an average number of the individuals in the area that you're surveying. So abundance means how many individuals. Pretty easy, just remember that word. So abundance, we already know that you can count numbers of individuals either by census or by sampling. Census is usually not done. Honestly, unless you can absolutely count every single individual, like it's pretty easy to count the trees, we could count them by census, but most of the other stuff we cannot count by census, we have to count them by sampling. So we will mainly stick around these sampling counts here. Now, if they're ones that are easy to identify, it's very easy to count the individuals and find the individuals, like trees or shrubs or ferns. We will normally do a sample count, which means we pretty much count up how many are in our quadrat. And that's pretty good. You can count up, like here, they can easily count up how many different plants are in that quadrat. Quite simple. However, if you tried to count how many lichen are in this quadrat here, you wouldn't be able to do it because you actually can't see all the individual lichen. They grow as a colony. So the question is, well, how do I count the individuals there? You can't. All you can do is, okay, now I've tried to scribble this on my trackpad here. All you can do is try and estimate the amount of area that they have. So let's see if this works. I'm using my trackpad here, so it's not as good as what I was using before, but it might help here at least. Basically, I'm trying to outline all of the type of white lichen, like that's one species of lichen. Then the other colors are other species of lichen. But for this one in particular, I can't count the individuals, so what I would do is highlight and estimate the amount of area that they take up in all the quadrats instead. So I've broken this area up here into 10 by 10, so I can estimate the percent area that they cover by looking at how many quadrats that they actually fall into. Now, you don't have to estimate it perfectly. The rule of thumb when we're counting up with quadrats and looking at area is, if it covers more than half of the quadrat or more, then we count it. If it covers less, we don't. That's a much easier way than trying to figure it out and measure it all out perfectly. So this one here, I would say he definitely is in that quadrat, and each one of these quadrats is 10 by 10. It's going to be 10% and 1%, yeah. So because there's going to be 100 squares in there, so he's going to be in that quadrat, that one, that one, that one, not that one because he's not even covering half, not that one, he's not covering half, not that one either. And you might think, well, shouldn't you count every single quadrat? Well, no. When you do the same rule for all of your quadrats in the same way and work it out, it actually tends to average out quite well. So I would actually count that one there. So we'd have, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maybe 13 there. So 13% area is covered by that one type of lichen. That gives me a relative abundance, a percent abundance based on the area that they're covering, because I can't count the individuals. So that's what we do when we're doing it with like grasses, where they're so abundant and so tightly packed that you can't actually separate the individual grasses from the other grasses around them. Our school oval is an example of that. Or where you've got so much things like lichen and that grow in together, that to count the individuals you literally have to destroy the area by pulling them apart in order to get a count, and that's not the way we want to do it. In ecology, we want to watch it grow and change over time, so you can't destroy an area to sample it. So we use relative abundance, or looking at the area it covers instead. So you can do that for basal cover or ground cover. That's a ground cover one there. Canopy cover, looking at how much canopy is actually covering your quadrat. Or leaf cover, that's a measure of shadow cast. Honestly, never used it, wouldn't worry about it, but it's in your textbook, so I'll put it there. One thing I will mention is basal cover. That's looking at, if you looked at everything on a profile, like, I'm going to try this with my trackpad, like that's your hill, and there's your trees. Pretend they're your trees going down. They actually measure the amount of area the trunks take up because that is a pretty good estimate of how much basically real estate those trees take up. If you look at how much area their trunks take up on profile, and that's what they call basal cover. I've never used it much in the past, but when you work with profile ones, you'd absolutely use it. And as you can see here, these trunks take up a large amount of the area of my hill as we go down. Last but not least is percent frequency. Percent frequency means that you essentially count up. If you've got a 10 by 10 quadrat like this, and for some reason you can't actually count the area that they take up, you can at least count the number of quadrats that they pop up in. And when you do that, you can actually get a pretty good idea of how frequently they're popping up or appearing, and you use that frequency count as a relative measure instead of area. We won't tell you to use that unless it's for a very specific type of species. So for now, do sampling, where you count the individuals, or area, where you count essentially the amount of ground covered by the individual in order to get an idea or a relative abundance. And remember the rule when it's area. If it's half or more of the little square in your quadrat, when you've got a 10 by 10 broken up quadrat, that's where you use those little squares that are broken up. Half or more you count it, under half you don't. Pretty easy rule to follow once you get used to it. There's extra videos I'll chuck in after this that will go into using quadrats in more detail for the rules, but for now that will get you through.